Okay, hi everyone. I guess I couldn't give a better introduction than she did, so I'm not gonna really waste your time on more introduction. But I'm Zahra from Keysight Technologies, and today I'm going to discuss about SBOM, software bill of materials, and also firmware analysis, and provide real-world case studies of the issues that happen that using SBOM generation and firmware security analysis, companies could get full visibility over these devices. And after that, I'll provide some examples of firmware risks and also some mitigations and recommendations. But before going to the presentation, if you're more comfortable, I'm happy to ask you to come a bit coming forward in the seats, which are completely empty, if of course it's more comfortable for you. And by the way, if you pay attention quite well and at the end ask very smart question, in addition to those federals, we'll also provide 3 backpacks, including some Keysight chargers, pens, and stuff inside, and we'll give it to the first 3 who ask the smartest questions. Okay. So first of all, what's SBOM, okay? First of all, software bill of materials are actually all of the third-party components or inventories inside a software. Imagine like a food, okay? A food has ingredients. Those ingredients can have also some other ingredients as well. This is the same story in software, okay? So the software can have several third-party components, libraries, and everything inside it, okay? And the software bill of material, like the name of the component, version of the component, license, and if there is any CV in those components. And usually, actually, it is essential to be able to understand the full supply chain of the devices and even software for security and compliance. Okay. Basically, SBOM is important for 4 main reasons, okay? And the first thing is security, okay? First of all, you need to know what component you have, what version you have in order to be able to identify vulnerabilities and their CVs. Or you need to have a list, so tomorrow if there is a new vulnerability, you can get informed, okay, about the new vulnerabilities. The second thing is compliance, okay? Lots of these developers actually integrated some components which are not really legally compliant, okay, to be able to be included in the device. For example, if you integrate GPL code, basically, and if you change that GPL code and add your code, basically, if the customers request that or everybody requests that, you need to share that, okay? So it also brings visibility over the compliance as well. The third thing is risk management, okay? It actually enriches the risk assessment. So there are several criteria to assess the risk of these devices, okay? And then SBOM generation and firmware analysis can enrich the risk data and provide a full visibility over the risk of the devices. And last but not least is supply chain transparency. I'm sure a lot of people who know this market SBOM, they expect it to be called software transparency solution or something like that. So we have basically 3 main standards for SBOM generations, okay? The first format is SPDX. SPDX basically mainly used for legal team or, legal department or compliance check and things like that, for example, for checking the license and things like that. Then Cyclone DX is another standard which is mainly used for security professionals or security researchers. And last but not least is Suite, which is good for software asset management. Basically, this is good. So whenever, let's say as a company, okay, you have several softwares or several devices, okay, and each of them have their SBOMs, okay. There should be generated in a specific standard format to be able to import it to your SBOM management solutions. And that's where these formats are useful. And in addition, we have several regulations actually that kind of enforce the SBOMs, okay? They can be international, they can be industry specific, and everything started with US Executive Order 14028 3 years ago, which enforced all of the solution providers for the US government to provide a list of all of the software bill of materials that they provide, and basically came after Log4j vulnerability. How many of you have heard about Log4Shell? Okay, quite a lot of people actually, so that was actually the main issue, okay? When Log4j was identified, nobody knew where it's really used. And I'm sure, I mean, there are still a lot of companies, and I'm always asking them, there are still a lot of companies that don't know if they have vulnerable version of Log4j in all of their devices or not. If any of you disagrees with me and knows all of the devices and is sure that all of the devices is free from vulnerable version of Log4j, please raise your hand. Okay, there is no one. Good. And then another, I mean, there are other standards, but the most important one, especially because we are in EU, is EU CRA, or Cyber Resilience Act. How many of you have heard about EU Cyber Resilience Act? Good, okay. It was, if you have heard about it, you know that it has been enforced actually this month, okay? And companies have 3 years maximum to follow that, okay? For some requirements, such as reporting the exploited vulnerabilities, it's even less, okay? And then, CRA, of course, has several requirements, and SBOM generation is one of the requirements. Basically, if you don't really follow CRA, Cyber Resilience Act, you cannot export your product in EU, okay? And if you export it and then they find that you don't follow it, then you'll pay 15 million fine or 2.5% of your revenue. Okay. Then, I want to discuss a little bit about firmware analysis as well. Firmware is basically the whole software stack, the brain of this device, the operating system of this device, okay? And then firmware analysis is a special examination of these devices to an XIoT devices. And when I say XIoT devices, I mean all of the connected devices, basically. Because when we say IoT, they all think of those sensors which are connected to cloud, okay? Basically, XIoT is more than that. It's enterprise IoT like routers, switches, cameras. It can be OT devices like PLCs. It can be medical devices or several devices that you can imagine, okay? And firmware analysis is an examination of this firmware, okay? To be able to uncover vulnerabilities, security issues, configuration flaws, and stuff like that. Okay, and the good thing about firmware analysis is that it gives you an inside-out point of view, okay? Let's say you have Tenable, you have Qualys, even you have products like Armis, Nozomi, they all can scan your network, okay? And can give you an outside-in point of view of your assets, okay? They never know what's going on inside those devices. Those devices are always black box towards them. But firmware analysis actually gives a full visibility over those devices and gives an inside-out point of view. So using firmware analysis, you can do a lot, actually. Sometimes when I show firmware analysis, and especially automated firmware analysis to people, they can't imagine how much information they can get out of just analyzing a single binary firmware. The first thing is actually SBOM detection. Using firmware analysis, you can identify all of the third-party components inside these devices. And also they can map them to their CVEs, or they can even be identified if there is a new CVE available. The second thing is potential zero-day detection, okay? There are several legacy components inside these devices. Again, recently there was let's say an issue from CISA and FBI based upon the analysis even of the most famous devices like Cisco, Palo Alto, Ivanti, very famous devices, okay? And they found command injection vulnerabilities in these devices, and basically because there are lots of old code bases in them. And then they came back and say, okay, start with the security by default, by design, but how about those old components? Okay, you can really develop the new components in a secure way, but how about lots of millions of old components in those devices? So you should be able to analyze the firmware to be able to identify those potential zero days. And then weakness detection. You can identify default components or configuration issues, even default passwords, keys, and things like that using firmware analysis. So first of all, I'm giving you an example, a case study basically of RPL 20 vulnerabilities. They are not new, of course. RPL 20 was even identified in 2020. So how many of you know about RPL 20? Okay, basically this was REPL 20 were a set of 19 vulnerabilities in TREC TCP IP stack. Basically there's a TCP IP stack called TREC, mainly used in embedded and IoT devices, okay? And it handles mainly networking functionality. And it was there, actually, this vulnerability was there for the last 10 years before it was identified in June 2020, okay? And basically those vulnerabilities could result in, remote code execution, even, denial of service or information disclosure. And the problem was that there was several issues when these vulnerabilities were identified. And mainly it was inconsistencies in reporting, okay? First of all, we had a problem of incomplete vendor listing. If you go to the CVE, NVD database, okay, of the CVEs, there's a vulnerable configuration that lists all of the vendors, okay? And usually it's not complete, okay? When a vulnerability is identified, there are several vendors that are using that component which are not really listed there, okay? That happened in this case, REPL 20 as well, because even several vendors used OEMs or even used another name and couldn't identify they even have TREC. And the second thing was that even MVD was not complete. So how many of you know who can add CVE? Who can really request for CVEs? Who? Everyone, actually. Everyone can go and ask for a CV, okay? If you, as a security researcher, go and find a vulnerability, you can request for a CV, okay? So everyone. And based upon that, of course, there are some back and forths with vendors, and there are some, researchers and anything, but the things which are published in MVD database is not always complete, okay? There are several missing things. And the last problem was, of course, delayed in vendor advisors, okay? Vendors took a long time to provide with the advisors, okay? For example, Schneider Electric came with advisors and patches after 4 months, okay? Rockwell after 5 months, and Intel after 6 months, okay? Even these were really fast vendors. So it's a long time, actually. It's just required for, one day after, exploit is published, 50% of the vulnerabilities get exploited, okay? So it's very important to address this issue as soon as possible. And the reason was, of course, the main reason was complex supply chain security. Lots of these vendors didn't have SBOM generation and didn't have any idea if they have TREC. The second thing was their lack of visibilities, okay? And the third thing was the resource constraints. So whenever a vulnerability is reported, it also takes some time for the manufacturer to really look into it, understand the impact, and also develop a patch for it. And last but not least, especially in OT space, you cannot just update whenever the patch is available, okay? Sometimes you can, but in OT space, industrial space, or some critical infrastructure space, it's not possible, okay? You need to wait, and especially in those environments, availability is important. So you need to wait until you can apply the patches. The second thing is, the second case study is regression vulnerability. This is, how many of you have heard of it? Okay, so this vulnerability was identified this year on 1st of July, okay? And then many industrial devices, and not industrial, of course, even enterprise devices, even your desktop, basically, Linux system had vulnerable OpenSSH version, okay? And it could expose the devices to full, unauthenticated access and full exploitation of those devices, okay? And then we analyzed, of course, several devices and things, okay? And then we tried to analyze a PLC device from a German company which is using critical infrastructure, and the company that has a SBOM solution to check how long does it take until they fix it. Actually, they were vulnerable. They had a vulnerable version of the OpenSSH, and it took them 23 days after the exposure of the vulnerability to fix it. So from 4, 5, 6 months and SBOM generation, having an SBOM generation and management solution could help them to reduce that in 23 days, which is really important. Of course, not perfect, but very important. Okay. Now I'm talking about what are the stuff that you can really identify using firmware analysis, okay? The first thing is those vulnerable third-party components. As I told you, SBOM, software bill of materials. Let's say when you have a firmware, you have several components. And in every component, in every firmware we scan, we can identify several components. And a lot of them have CVEs, okay? Known vulnerabilities inside them. So for example, if you use, let's say, again, those network-based devices like Tenable, like Qualys, maybe you find 2, 3, even 4, even sometimes no vulnerabilities, okay? But if you go and do the firmware analysis and identify all of these components, then you will identify several CVEs inside these devices. And this can be just identified using firmware analysis. The second things are, as I told you, are potential 0 days. Basically, several binaries, compiled C codes, legacy codes are inside firmwares which are vulnerable to potential command injection. Basically, command injection is a vulnerability when a developer enables the execution of a specific command and doesn't validate the input, okay? So for example, if I have a, let's say, system popen or exec command of ls-la, it would execute that. But if I don't validate it properly and have exec ls-la, then semicolon rm-rf, then that would actually execute that and then remove everything you have in your system, okay? And this can have several consequences. Of course, depends on the type of the vulnerabilities. Then stack buffer overflows are another type of vulnerabilities, which we see several times in these IoT devices. And then format string vulnerabilities, another example of potential 0-day vulnerabilities which are inside these devices. Private keys. This is a very interesting case, okay? So I'm sure you have heard about a lot of cases that they come back and say, oh, we have secure devices, our traffic are encrypted and anything. And then they put the private key inside the firmware. And that private key is actually in the firmware, which is, even it's not changed. Basically, if you get the firmware and analyze the firmware and extract the private key, you can actually decrypt the whole traffic. So your encryption is actually useless if you have private key inside the device, and which is not, of course, unique to the device. So this is also something we have found in most of the firmwares we analyzed. Or weak certificates, okay? Then another issue is that having several weak certificates in these devices, which even, for example, in this case could result in a user to really create and forge a specific certificate, okay? But these are also there and very common in these devices. And then this is a result of analyzing a very important secure industrial router, okay? They have telnet inside it. Can you believe it? I'm sure, no one expects to see telnet anymore, okay? But when we analyze it, we find these kinds of things. A very secure industrial router, and the company, even we didn't want to show the name, especially in this event. So, but this is there actually, and this is again because firmware is again black box for several vendors, okay? And then another example of configuration issues are guessable SNMP community string. You can find several configuration issues, but this is just one of the examples. Basically, first of all, most of them don't use SNMP v3, okay, which is actually a secure version, has supports encryption and the other stuff. But in SNMP v2, they even use the default community string, okay? Which means actually in several cases the attacker there's a potential for the attacker to change the configuration. Even some of them can be very strict configuration of these devices. And then another thing is exposed binary with missing exploit mitigation. Basically, as a developer, if you know a little bit, just a little bit about security, at least try to compile it using the secure flag, like PIE. Like ASLR, okay? But when we analyze firmware, we identify several binaries which are exposed over internet. Even those default secure flags are not used whenever they compile these devices, okay? Which of course shows how awful is the situation of these devices. Okay, so First of all, this is a very important slide, and I wanted to really discuss about it because there are several misconceptions, especially of those device deployers, basically those who deploy these devices in their network, okay? The first assumption is that they think latest firmware doesn't have any known vulnerabilities. That is completely incorrect. Why? Because when device developers or manufacturers want to create a firmware, they integrate several third-party components that they don't manage. So if you have Windows or if you have normal Ubuntu or Red Hat, there are actually teams who are managing those packages and also components in those package managers. And if there is a new vulnerability, they would update that. But these device developers, even the most famous one, just get these components, developers integrate them, and then they don't really monitor these components for any vulnerabilities, and they don't even patch whenever a new vulnerability is available. So the latest firmware doesn't mean that it's a secure firmware. The second assumption, this is very interesting, is that the risk is taken by the manufacturers, okay? So they say, okay, this is a risk, manufacturer should take it, and we don't take any responsibility. And the point is that we always tell them, as soon as you buy the device and use it in your network, you actually assume the risk. This is your network which is in danger if a cyber attack happens. Like, for example, if you go and buy something which has peanut butter and you're really allergic to peanut, and then something happens to you, and then come back to everyone and say, oh, the one that sells it to me should take this risk, not me. Really doesn't make sense, okay? And the third thing is that the device is not connected to the internet, so there's a little risk. Well, I have to tell you, Shodan and Census really disagree with this claim, okay? Even, there have been several cases that people thought their devices have been disconnected from the internet while they were actually accessible, okay? But assume that, your device is not really connected to the internet and you're right. How about the lateral movements? How about the insider threats, okay? How can you really, check for them, okay? And then last but not least is that they say, I cannot do anything about it, that's why I don't want to know about it, okay? And then I usually tell them that, well, if you're in cybersecurity world, actually the blue pill is not really an option, okay? This is just an option which is called red pill, okay? And if you don't really want to know that, then you're in the wrong industry, okay? Because this really puts you and your organization in danger, okay? And by the way, there are a lot of things that you can do about it if you know about it. But you cannot do anything about something you don't know, okay? And these are some potential mitigation they can do, even if there is no patch available, okay? You can do virtual patches. Basically, you can configure your firewall and set an access control list or define an IPS rule at least for some of the vulnerabilities to be able to do that. Or isolate your devices in a separate VLAN, okay? Or if you know their risk, you can, of course, monitor the traffic for potential, malicious activities into that device. Or regularly review those logs if you know there are some vulnerabilities that could put your devices at risk. And you have to always inform your vendor. Sometimes security professionals, when we go to vendors, they say, okay, we are not really reached out by customers, okay? You have to be the one who actually help them and ask them to secure your devices. You need to request for security. You need even to include it into your contracts, okay? That, hey, we want security, and if you're not compliant, then this and this, and we have the right not to work with you. And another thing you have to consider in your contract is to be able to have access to the firmware, to be able to do this analysis by yourself. And then if they don't care, then you have other options. There's a very big market. Replace your devices, okay? They don't care about you, they don't care about your security, then replace them with someone who cares, a vendor who cares. And I'm sure there are a lot of them care, actually. So final insight and recommendations. So first of all, as I mentioned, hidden risks persist in the firmware, okay? Even the latest firmware version can have very critical risk even. Awareness is non-negotiable. Don't forget, blue pill is not an option here. And then you can of course use an automated solution. You don't need to really do everything manually, okay? You can use firmware analysis, automated firmware analysis to analyze the firmware and even utilize the solutions that you already have to really secure your firmware, secure the vulnerabilities. Thank you, everyone. So, any questions?
We have already, oh, wow, how many questions?
Wow.
Hello, thank you for the talk. I have a question from automotive field. I'm from the automotive and vulnerability management process, and the SBOM generation is now a must in the field. But we saw that the vendors for the tooling, they are not properly detecting all the libraries, all the contents of the SBOM. We are working with the vendors, but how do you solve this in your field? Because we have versions that are not properly detected, libraries that are not properly detected. How did you handle this problem?
First of all, that's a great question, so feel free to share one of those backpacks with him. Okay, wonderful question. Yes, SBOM generation solutions are not perfect, okay? We still have a big gap there, okay? There's still a big gap here, and I agree with you. I mean, if I want to tell you, we cover 100% of the SBOMs, that's a lie, either Keysight or the other companies, okay? But we have to start with something. Do you agree? I mean, we have to start with something and create based upon, okay? And there are solutions, okay? Basically, as a company, we are working on some innovative solution to improve this coverage and accuracy, okay? I'm sure the others are also trying to do, okay? But you have to start with something, because actually perfect is the enemy of good, right? Okay, so at first try to be good and then work upon it to be able to be perfect. But yeah, you're completely right.
Hello, thanks for the great presentation. I have a question about vendor misconceptions, not only customer misconceptions, of which some you listed. Do you feel that the vendors, because some of these vulnerabilities that you showcased are also because vendors think they expose some interfaces, some management interfaces to the internal network under the assumption that the internal network is trusted, whereas the industry should move away from this thought that the internal networks are trusted. We should go to zero trust networking, where you cannot trust the internal network because you can have malware on the internal network that does lateral movement, right? Mm-hmm. And then other things like hard-coded keys or passwords is because they encrypt the firmware and they think that no one's going to look inside, so it's sort of like
security by obscurity. Yeah.
So do you think there should be more pressure on how we can put more pressure on vendors to actually change this mindset, especially in the embedded device space, because it's more prevalent there than in the traditional desktop applications?
Well, thank you for your question. Another good one, another backpack. So basically, based upon the experience, I can tell you there are basically two ways. I mean, people thought there are three, but I would say two, because a lot of vendors basically don't care about even their reputations. Although we think they care, they don't care. What can really enforce them or really motivate them to do that is first, request from their customers. So if you are their customers, you have to ask them. And not only ask them, put it in your contract, okay? Put it in your contract that, you should provide a device for us that, assumes zero trust, or you haven't really, provide me the unencrypted firmware version, okay? Because in a lot of cases, as that gentleman mentioned, there are SBOM provided, but they are not accurate, okay? So you need to verify even. And even let's say a SBOM is accurate, okay? If tomorrow a new CV is available, you need to be able to monitor it and be informed before really waiting a long time for the manufacturer to do that, okay? So you need to set it in your contract, and as a user, you have to ask them, and this is the first motivation. The second thing is compliance, okay? As I told you, there are some standards from the government who are trying to enforce them to be able to do that, especially, for example, those who provide solutions for the government. Or even the good thing about Cyber Resilience Act is actually it's about every product with a digital element that they manufacturers should provide SBOM. But again, the user should really ask. So my feedback is that the first thing is that the user who uses this should request for this. This is the most important motivation and the first thing you can do.
Thank you. The next two questions, yes.
Can you hear me? Okay. So I was wondering if there's such a big delay between the disclosure of exploit and the actual patching. Does this time represent, are there any recorded attacks in this time? So is it an actual problem? Like, what are the statistics of it?
Okay, so in terms of just the date that the exploit is reported and the date that an attacker exploit that vulnerability. So based upon CISA, so for example, based upon CISA, there are 4% of vulnerabilities with public exploit available. Okay, and according to CISA, 48% of those vulnerabilities are exploited on those devices on day 0. Okay, another 30 or 40% I think are exploited in day 1, okay, and then the other day. So most of those publicly exploitable vulnerabilities are exploited on the first or the second day, on the same day or on the first day.
So improving this time wouldn't help that much.
It could help because the point is that that's why I'm saying the users should have their own SBOM generation and SBOM management. And if you remember, I also suggested, virtual patching. So, for example, really, block it in your firewall, add a firewall rule, or monitor it, do something, some virtual patching until the real patch is available.
Thank you.
Sure. The last backpack until, because it was also a great question.
And there is a gentleman with bright shirt. Yeah, thank you.
Thank you. Thank you for your presentation. Your studies and problems discovered are very interesting. I wish to ask if we have any chances to find online some catalogs of these outdated machines, even other type of hardware equipments which need to be updated.
Okay, so you're asking about some vendors who have, let's say, these outdated systems, and you want the vendor list, because I didn't understand the question.
No, maybe it will be your next step for this research when a group of good initiative will deliver some online catalogs for know if I have some equipment that to be updated. So to identify those equipments which will need to be updated soon.
Oh, okay, yeah, you mean some, so basically, there are some, for example, for OT devices, let's say those devices which are used in critical infrastructure, CISA has another advisory, which is separate even from NVIDIA, okay? So for them, it actually publishes that, so but it's in a separate feed, because those devices are important. And then also, some of the vendors, even some of the users who sign up for that would be informed whenever a new vulnerability or an outdated component is in those devices, okay? But it's not for all. We don't have really a public feed for all of the, let's say, component, especially all of those devices with vulnerable components. That's why we tell the users to really buy an SBOM solution and try the firmware by yourself to be able to identify that by yourself. And even the interesting thing is that for the CISA, even CISA reports those, highly exploitable, vulnerabilities in those devices. There might be even several components in those devices with vulnerabilities which is not reported in CISA. So in any case, you have to get the firmware and analyze it by yourself to be able to make sure of that. You shouldn't really rely on, third-party feeds, government initiatives, or things like that.
Thank you. In the first.
Thank you. My question kind of overlaps with the first question. So let's say someone has a good SBOM tool process, and they identify all their third-party components, and they're just starting out. And then they're like, wait a minute, these third-party components have their own third-party components, and so on. You start to have this huge dependency tree, which can be overwhelming. What might your advice be in that situation? Start with degree 1, or hey, does degree 6 dependencies mean we're vulnerable?
Well, it's actually, that's a very good question, because you can have several third-party components, either, direct or transient, okay? And what we advise is that because the SBOM solution provide also, the information about CVs, exploitabilities, or even EPSS score. So we always say, look at those components and prioritize first of all based upon if there is a public exploit available on them or not, okay? This is the first step. The second step is if there is no exploit available and you address all of those vulnerabilities with public exploit, go and check their EPSS score. You know EPSS score? So yeah, so the second thing is looking to EPSS score. Just for everyone's information, EPSS score is actually published by FIRST, okay? It's the probability of the vulnerability being exploited in the next 30 days. And this information changes every day. So today, the probability might be 1%, tomorrow it might be 90% based upon new information. So go to the vulnerabilities with highest percentage of this scoring, and then try to address them and go, based upon that. But if this, let's say, vulnerability is a, let's say, not indirect component, then it doesn't matter. You need to go and address them based upon this priority.
Thank you, Zahra. We do have time for 2 additional questions, one in the back, one in the front. I'll give the Microsoft in the front.
Hello. I have a question regarding the treatment of providers that do not give the firmware, of course. Usually they prevail this aspect by intellectual property or management. So they say, especially for FPGAs, the products that contain IPs, but they don't provide the firmware also for the other components.
Yeah, I understand that. So first of all, it depends on the firmware. In most of the cases, and this is not my, let's say, statistics. This is, for example, according to Synopsys. According to Synopsys, 96% of your code bases, is the open source third-party components, okay? So what they are talking about is basically maybe that 4% of their product, okay? And also in a lot of cases, even the way they create the firmware is not, they even use open formats, okay? So it's not, mostly in a lot of cases it's not their code, but I understand, for example, it might be an FPGA or something like that, and in those cases, first of all, I would say, it depends on the device. For example, so we have heard this from the automotive companies that they say, my firmware is very, secure. It's my IP there, and I would tell them, every attacker can go there, basically open the device and read it from the memory. That's the same as true. If the device is available, the attacker can go and read the firmware there, okay? So what's your problem here? Even always the keys inside the device, okay? So everybody can get. So is it better for me as a customer to scan it and analyze it and identify the vulnerabilities, or a hacker to get this device and get the firmware and analyze it, find the vulnerability and exploit me? That's why I'm telling and I'm insisting the users to ask for the firmware, unencrypted firmware version, and don't let them use these excuses of IP rights and stuff like that.
One more question and we're done.
I wanted to ask, you said that anyone can report a CVE if they find the vulnerability. And I wanted to ask, what's the process to do this? And if it's harder for someone with less experience that hasn't done this before to do it than someone with more experience?
Okay, so first of all, I suggest you not to do that because it's a very long process. But yeah, if you really find a new vulnerability, you have to report it. There are some third-party organizations who can really, mediate this process. For example, in our case, because those stuff that we found were really critical infrastructure, we always use the mediation of CISA, okay? But there are several mediators, okay, that can be as a mediator, and you can approach any of them, okay? And as for the CV, basically there are some forms that you need to, fill in order to get the CV, and then either you directly go and reach out to those third party, okay? But if you go there and reach out to them, they will take forever to be able to fix that. That's why I'm asking you to use those, mediatory organizations, because especially someone, I mean, an organization like CISO, because they can enforce them to fix it faster. And then there's a process to, verification, to giving CVSS score and stuff like that, and then after that process, it will be published. And of course, I mean, in a lot of cases, if the vulnerability is really critical, usually the manufacturer says, hey, I need some time in order to fix this and report a patch, basically. And usually, in a lot of cases, the vulnerabilities are just published after the patch is applied. That's why the interesting thing is that usually, even sometimes you might see a CVEs whose names has, for example, 2022, 2023, but the date of the CVE as a new is usually 2024. So 1 year, 2 years is the same reason that the process took so long, and also the patches were applied. So this process can be actually a very long time. So as a security researcher, it's a good practice, but I'm always suggesting to people, don't really waste your time, because it's a very time-consuming process, and you can get a lot of, back and forth and really awful feedback from the manufacturers, because they don't want, usually they tend not to accept they have this issue.
Thank you very much. And I guess with this, we can close the session. We still have one backpack. Shall we give it to the last question?
Where's?
On the last chair. Is there any? Yeah, there is one.
Oh, yeah, there's one. I thought we
To the last question?
Okay, yeah, why not?
Okay, I'll do it. So thank you very much,
I thought it's
Zahra. Thank you very much. Let's
Sure.
give Zahra a round of applause.
Thank you.